Hi, I'm Jesse with Mastercam, and in this video we're going to talk about Mastercam's multi-axis Deburr toolpath and how tool center point control can make programming and setup a breeze. Tool Center Point Control, or TCPC, is a software feature in the Haas control that makes setting up 4- and 5-axis jobs as easy as setting up a 3-axis machine. It allows you to place your part and fixture anywhere on the machine's table or platter, regardless of the location that was programmed in your CAM system. TCPC will automatically determine the difference between the WCS programmed in CAM and the center of rotation within the machine and apply the appropriate offsets in real time. Now that we understand what TCPC does, let's look at a real-world example. We're going to deburr a handful of edges on this mold core for a computer tower. You'll notice that we have a plane called WCS G54, and that it's different than the Mastercam top plane, which represents the center of rotation on the UMC. This difference isn't required for programming this part, but it's a good way to help emphasize the flexibility of TCPC, or G234, on the new Haas control. Typically, without TCPC, we would need our G54 offset down at the center of rotation not only in Z, but it would need to be perfectly aligned in X and Y as well. This is because machines without TCPC are only aware of the center of rotation of the machine itself. If we don't set up our part file correctly in CAM before running the code at the machine, we can end up with broken tooling, damaged parts, or worse. Thanks to TCPC, we can put our work offset anywhere that makes the most sense. In this case, we're placing it at the top center of our laying fixture plate, which will be easy to probe at the machine during setup. Now let's look at programming the Deburr toolpath. This part calls for at least 15 thousandths edge break. Typically, this would be done by hand after the part was complete, but we're going to integrate this into the machining process to save time and reduce the chance for human error. To do this, let's go to the Multi-Axis Gallery on the Toolpaths tab and launch Deburr. For this operation, we'll use an 1/8 inch ball end mill. Keep in mind that Multi-Axis Deburr only supports ball and lollipop end mill tool types. The holder is already defined and is a shrink fit with 3/4 of an inch stick out. On the cut pattern page, we can select the entire part by triple clicking on it. We now have the option to have Deburr automatically detect which edges need to be broken, or we can use user-defined edges. Since we're only worried about a few specific edges, we'll define them ourselves by selecting the solid edges right off the model. Let's start in Edges mode and select the first edge. When the chain encounters a branch point, we're asked to specify which direction the chain should follow. We can either click on the red arrow of the gnomon to advance the chain, or click on the next segment of the chain directly. Additionally, we can use the buttons in the chain manager to advance the chain. Once this feature is done, we'll chain the top edge of this pocket by selecting Face as the method and simply clicking on the top face of the part. The last feature to be deburred is the recesses in the bottom of this center pocket. We'll choose Cavities and then select the face at the bottom of the pocket. It isn't necessary to use all these different chaining methods, but it is a good opportunity to show you how flexible chaining in Mastercam is. We'll end selection and then set 18 thousandths as the edge break to make sure that we meet the called out edge break tolerance of the part. Moving over to the tool axis control page, we could use 3+2, which will lock each edge break to a plane, but since the UMC can cut in simultaneous 5-axis, we'll use that option instead. Let's use the fixed to main axis strategy and set the direction to Z. The resulting motion will be mostly 3-axis, but where needed, this tool axis control setting will allow the tool to tilt away from collisions. On the linking page, we'll select a user-defined clearance plane along the Z-axis, and we can right-click and choose Z coordinate of a point. We will then select a point on the top of the model. Let's add about 1 inch extra onto this value to give the tool a little more clearance. Let's also replace the rapid moves with feed moves and set the speed to 500 inches per minute. The UMC prefers feed moves during plane changes, so this setting will result in smoother rotary behavior at the machine. Once the toolpath is generated, we can review it in Backplot. As we scrub through Backplot, it becomes evident why multi-axis capabilities are so important. The tool is able to tilt in different areas to avoid collisions, all while maintaining the exact edge break we specified. If this were a 3-axis operation fixed to Z, the edge of the holder would collide with the part and we'd be forced to use a much longer stick out, which would reduce rigidity and increase the chance of chatter while in the cut. Now that we're satisfied with how the Backplot looks, let's move over to the machine and talk a little bit more about how the TCP functionality on the UMC helps us cut a part like this. Earlier, we talked about how utilizing TCP makes the relationship between the center of rotation and the location of the fixture and part less important. When this fixture was bolted down, we didn't worry about the exact location on the table. We simply picked up the ground face of the part to be parallel with the x-axis and set that as the c-axis rotation for our G54 offset. Next, we probed the center of the fixture in x and y and touched off on the top for z. TCP will track that work offset against the center of rotation in real time when we hit cycle start. Not only did this make this setup simple, it also means that if we need to run this part again in the future, we don't have to worry about getting the fixture back in the exact same location or needing to make any changes to the plane data in Mastercam. Simply pick up the location of the fixture again and let the part run. And speaking of letting the part run, let's look at this Deburr toolpath in action. Notice how the ball end mill comes down and just touches the edge of the part, removing any burr left by the previous operations. Also notice how the tool only tilts when it needs to. With just a few clicks in Mastercam, we're getting a nice consistent edge break that meets the specifications of the part. And since this is being done in the machine, we could cut as many of these as we wanted, and that edge break would be perfectly consistent on every single one. If you're running a Haas next-gen control for 5-axis machining, and you're not utilizing tool center point control, we really hope this video has shown you why you should be using it going forward. The combined power of Mastercam's Deburr toolpath and the Haas next-gen control make jobs like this repeatable, reliable, and safer, which is a winning combination.